Hey guys, welcome back to AlgoYogi. Now we are doing array and hashing series. Our next problem in the list is majority element. So let's go to LeetCode. The problem is really simple. Given an array nums of size n, return the majority element. Now the majority element is the element that appears more than n by 2 times, where n is the size of the nums. You may assume that the majority element always exists in the array. It's a really simple problem, and this problem has like a lot of solutions, and of course with different time complexity. And we will talk about brute force solutions and then get to the most optimal one. Well, so we are given this array, and here we are trying to find the majority element. So what is the definition of majority element? Well, majority element will appear in my nums more than what? N by 2 times. All right, so what is n? N is the size of nums. Well, what are different ways of finding that out? Well, first, brute force solution would be, so the brute force solution would be first solution would be, how about I just count how many times each element is occurring. So if I just do basically nums count, so I'll just use in Python counter. You can just this basically works like a dictionary, so it's an inbuilt dictionary function. This will give me basically a dictionary of, at least if we're doing this example, then 2 will give me the count 4, and then 1 will give me the count 3. Now what I can do is I'll go over this dictionary and check if any key, or which key, not any key, because the answer is guaranteed to exist. So which keys value is greater than n by 2. So in this case, what is n? N is 7. So 7 by 2 is gonna give me 3. So 7 by 2 will give me 3, and then this count, 2's count is 4 is greater than 3. That is why my answer is 4. Answer is 4. So that is the brute force solution. Here the time complexity and space complexity. So time complexity is big of n, and space complexity is big of n. But this problem asks us that we should solve this in big of the time complexity will always be big of n, right? I don't think we can do better than that, because you have to get through all the elements, right? But we can definitely do better space complexity, right? We can do better space complexity. We can bring it down to 1. How do we bring it down to 1? Well, we can do 2 approaches. One is how about I just sort these elements. If I just sort these elements, sort all of them, so this will give me 1 1 1 and 2 2 2 and 2, and then I try to access the element at n by 2. What is that? That will be 7 by 2 3. So 0 1 2 3 4 5 and 6. What is that element at third? Well, since the majority element will appear more than n by 2, then it has to appear after sorting it at the middle element, right? It has to appear, because otherwise it's going to lie on either of these sides, either this side or this side, but since it's appearing more than n by 2, more than half of the times, then it has to appear in the middle as well. Either it was like, a greater value than what is in the middle, or either it's a part of the first half or the second half. Well, this brings down the space complexity from to big of 1, because we're not using extra space, but however, it takes the time complexity up to big of n log n, because we are sorting the elements. Can we keep the time complexity to big of n? Yes, we can. There is another solution called Bayer-Moore algorithm. That algorithm just works really on a simple principle that we're going to assume that one of these elements is, when we're going to go through all these elements with an assumption that the first element is the majority element, and then we'll keep a count variable and candidate variable, and we will keep incrementing if we keep seeing this element, and if we see a different element, we will reduce that count. And if the count becomes 0, that means we are seeing a new majority element, then we will switch to that element. All right, so let's do that. So in this Bayer-Moore, I think these were two guys who came up with this solution. Not for this problem, it's an algorithm itself. So let's go through that. So what we are going to do is we'll have count 0, and we're choosing the majority candidate, so I just call it candidate MJ. I'm just going to call it ME, not MJ, ME, majority element. And initially I'm just going to say none. I don't have anything. But for element, I'm just going to call it num. For num in nums, if this count is 0, that means it's time to choose a candidate, right? It's time to choose a candidate. So I will say that my candidate, so count will be 1, and before I say count is 1, I will choose the candidate, right? I will choose the candidate right here, and that candidate will be the current num, right? If I'm seeing, basically, if the count is 0, right? So what I'm going to do now is elif, if this num is equals to my candidate, then I will increment the count. Otherwise, I will decrement the count. Else, decrement the count. Right? So let me squeeze everything a little. All right, so I will decrement the count, and then I can just return the candidate. By the way, in this problem, it's guaranteed that we will have a majority element, so this will always return a candidate. But we can also check if whatever element we have chosen, then we can also check if this is the majority element, and you can just check with that condition that basically the number of times it appears in our list is actually greater than this candidate that we are choosing. But we don't have to, in this particular example, we don't have to like validate that. But let's see how is this working. So let's run it on our example, this example. So what's really happening is, initially I have my count as 0, and then I have my candidate. candidate majority element as nothing. Let's say null. Right, now let's go over these values. So what I'll do is I'm coming to the first element, which is 2, right? So if count is 0, which it is, so I will assign my candidate as 2, and then I will increment the count to I'll just remove it from here and here, and then I will increment the count to 1. All right, then next element, which is 2 again. So I'm seeing that it's equal to my candidate, so I will increment the count. So my count would be 2. I've already done that. Then I will come to 1. I'm seeing a different character, but the count is not equals to 0. What's happening is this will pass, because it's the else case, because I'm seeing a different number. Then I will decrement the count, so count will become 1 again. So this is cancelling it out. If you see this 1, I'm seeing it's cancelling one of the 2's count. And the reason we are doing it, if 2 is really the majority element, then at the end of the day, if all the other elements are cancelling the count of 2, then we still should left with 1 more 2. So we will still left with 1 count as 1 and is still candidate as 2, right? I will show you like why that's true. But I'm sure like it makes sense, right? If the majority element appears more than n by 2 number of times, then if it cancels its count 1 by 1 with other remaining elements, then there must be 1 more count remaining of that majority element. And then we come to another one. Now this time this 1 is going to basically make the count 0, right? Count 0, because these two 1's count have cancelled these 2, right? Then we move to the next element, which is 1. Now if you see so far we can't decide what's the majority element. If you really are trying to find out so far in the nums, that's the beauty of like for loop. You just you're calculating the answers so far in this case, and then you go to next one. Now you're seeing this one, and the count is 0, by the way. The count becomes 0, so that is why this will execute now. This will execute. So what will happen is I will override this 2 as my majority element as 1, and then I will make the count as 1. That's the element. Now second is going to be 2. Now this time 2 is different, so this will execute and it will bring down the count to 0. But candidate that I've chosen is still 1. Then I will see this 2 again, and what's happening is now the count is 0. Then it will overwrite this element with 2, because my current is 2, and then I will also change this count to 1. All right, and then now I will just return my candidate. So in this case, you can see that majority element is 2 and it's guaranteed. And along the process, you have seen that why are we overriding if you see something more than n by 2 number of times. So if something is really a majority element, then it will basically cancel out the other counts of the other numbers. And we are calculating it like immediately so far till that ith index. So now this is the best solution, by the way. This is the best solution, since its time complexity of this solution, Bayer and Moore, is actually time complexity is big of n. You go through all the elements once, and then space complexity is big of 1, right? This was the most important thing to achieve, because otherwise you can just have a map, count every number, find the one whose count is more than n by 2. So let's let's write the optimal solution. Let's write the optimal solution. You can write down the brute force yourself. So we'll say my count initially is 0, and my candidate, so I'll say majority candidate is none. Then I will go over all the nums. If count is 0, then I will say count will be 1, and this candidate will be the current number that I'm seeing. So I'm gonna just assume like this num is the candidate. If my candidate is equals to num, then I can increment my count. Otherwise, I'll decrement my count. I'll cancel out. If I'm seeing a different number, then count will be decremented. And then in the end, I can just return the candidate. Only when they're saying that it's guaranteed that this will, the majority element will appear. Otherwise, you can basically say you can have a for loop where you're going to count in the nums the number of times this candidate appears, right? And then you can just return that. All right, so let's try to run it. I'm gonna zoom out. We didn't do the validation step, but I'm sure there is another problem called majority element 2. We can do that there. Let's submit. Time complexity. So big of n, and space complexity. Space complexity big of 1, constant, 0.9. All right, so let's go back to AlgoYogi, mark this solved. Awesome. So keep coding, keep practicing. I know things might change, how interviews are done, but honestly, LeetCode is not about writing the code. It's more about approaching the problem from these, it's a problem-solving thing. And I think most of the problem in coding world are like it at least prepare you to approach these like data structure algorithm related problem. If you're doing it like nicely, sitting down, thinking, being intuitive, and then coming up with these different approaches, learning if you don't know, then learning more, then I think it's definitely going to help us. See you guys in the next problem.